So it is very possible at this point in time you've been wondering why on earth we're doing this factoring thing and what is the purpose that factoring serves. So we're going to see the answer to that in this video. We're going to learn to use something called the zero factor property that's going to help us solve the actual equations. We're going to solve applied problems, and we're going to solve a formula when factoring is necessary. So this is kind of the big picture. The zero factor property says that you can take factors and set them equal to zero, and then you can solve for the equation. So if I have these two factors, to solve this equation, I can set each factor equal to zero, and then I can solve it for x, which gives me the solution to the original equation. So these are the x-intercepts on the graph of that polynomial. I can check to see if they're correct by plugging them back in for x to see if I get zero, and that's going to be true. A quadratic equation can be written in this form. So remember, we did a lot with quadratics. And we like it to be set equal to zero. And the reason is because of the zero factor property. So when dealing with quadratics, we write it in standard form to make it easier to factor. So if I write a quadratic in standard form, then I can factor it completely. Then I can apply the zero factor property, and that will give me the solution to the equation, which corresponds to the x-intercept on the graph. So you can actually check this by graphing that polynomial in Desmos.com to ensure that it's at the right place. So here, I have to write this in standard form. I need it to equal 0, not 4. So I'm going to subtract 4 from both sides so that everything's on the left. Now I'm going to go ahead and factor it. I'm going to do 3 times negative 4, which is negative 12. And I'm going to look for the factors of negative 12 that add to give me negative 1. Then I'm going to factor by grouping to get this answer. Now I'm going to apply the zero factor property to set each parenthesis equal to 0 and solve for x. So I should check both of my solutions. I should go to Desmos.com and graph 3x squared minus x minus 4, and you should see the x-intercepts happening at 4/3 and negative 1. Here's another example. It's already in standard form, but I can probably factor out something to make my life simpler. So I can factor out a value, or I could see that 16 and 9 are perfect squares and that 24 is 2 times 4 times 3. So I could apply the perfect square trinomial formula. Either one's going to get you there. Then I'm going to apply the zero factor rule, and I'm going to get m is equal to negative 3/4. So if I graph this polynomial in Desmos.com and enter it as 16x squared plus 24x plus 9, because it's not going to recognize the letter m, you should see there's one x-intercept and it's at negative 3/4. This one, I don't have a trinomial here. So because I don't have a trinomial, the best thing I can do is just factor out what I can. I can factor a 2 out of both terms, an x out of both terms. Now this is going to be the zero factor property, but I'm taking what's in front of the parentheses and setting that equal to 0. Then I'm taking what's in the parentheses and setting that equal to 0, and then I solve. I'm going to be able to graph that in Desmos.com, and the x-intercept should correspond to the numbers that you found. Here's another example where I don't have a trinomial, but I could factor a 5 out. And when I factor the 5 out, I see that I have a square and then a square, and they're subtracted. So I have two perfect squares that are subtracted, and that's going to be the difference of squares. So I'm going to set each parenthesis equal to 0, and I'm going to get my x solution. I don't need to set 5 equal to 0. If it was 5x, I would set 5x equal to 0. But because there's not a variable in front of that parentheses with the 5, I'm only setting the parentheses equal to 0. Here, I'm going to go ahead and I'm going to FOIL or distribute through to get this simplified. I'm going to get all my terms on the left-hand side by subtracting x from both sides and adding 8. Then I'm going to factor this. The factors of negative 4 that add to give me positive 3 would be negative 1 and positive 4. I'm going to set each parenthesis to equal to 0 to get my solution, which also corresponds to the x-intercepts. Here, I need to get it in standard form. That 4x being on the right is causing a problem for me. So I'm going to subtract 4x from both sides. Then I'm going to make sure it's written in ascending order. Now, if you notice, every term has an x in common. So I could start by factoring that x out. Now I have a trinomial. I can do 3 times negative 4 is negative 12. What are the factors of negative 12 that are going to give me a positive x? I can do that whole factoring process, and I get x times 3x plus 4 and x minus 1. Now the zero factor property means I need to set the x in front equal to 0. I need to set the first parentheses equal to 0. I need to set the second parentheses equal to 0. And I need to solve for x. So I have 3 x-intercepts on this graph, which should make sense because it's a cubic. Now let's look at applied problems for the zero factor property. The length of a room is 2 meters less than 3 times the width. That's a mouthful, right? The area of the room is 96 meters squared. Find the width. Well, I know that as I read this problem, area is going to be the sides multiplied by together. So I need to assign a variable. So let's say that x is the width of the room. So I'm going to have that the length would be 2 less than 3 times the width, so 3x minus 2. And I know that area is 96. So if I draw this out, it's going to look like this. Area is multiplication. And then I want to solve this. And I can't solve this until I distribute that x through. And then I get the 96 moved over. Now I have a quadratic, and the way that I solve it is with factoring. And when I factor it, this is what I'm going to get. Now remember, I can do 3 times negative 96, the factors of that add to give me negative 2. Then I'm going to use my zero sum property, and I get 2 x values. Now, if x is the width of the room, a negative width doesn't make sense. So we can rule out that negative answer. So the only possible solution here is going to be 6 because it's positive. I can check my answer by plugging back in, and I see that I am correct. Now here's another example where we have a small rocket, and I'm given a quadratic equation to describe the rocket. And I want to know how long is it going to take it to be a height of 256? Well, if this function describes the height, that means I need to set it equal to 256. To solve any quadratic, you've got to get everything moved to one side. So I'm going to add 16t squared. I'm going to subtract 128t. Then I'm going to factor. So I can factor out of 16 to simplify things, and I get t squared minus 8t plus 16, which is going to factor to t minus 4 squared. I'm going to use the zero sum property to get t equals 4. You might need to pause this video and work through these steps on your own because we've already covered factoring, so it's not showing that step of recognizing the factoring process. So let's solve a formula for a specified variable when factoring is necessary. So if I look at this and I want to solve it for w, do you see there's more than one term with a w? So when you have more than one term with a variable and you need to solve for it, you're going to factor it out. So I'm going to take that w and I'm going to get those two terms by themselves. Then I'm going to factor that w out. Now I can divide both sides by 2h plus 2l, and I've solved for w. This is a trick you have to recognize. It's going to come up in the homework. When there's two terms with a variable, you isolate the two terms, you factor out the variable you're solving for, and then you're just simply going to divide.